Hey guys, welcome to 12.6. We're talking about vectors. So first of all, a vector has a magnitude and a direction. So it's going to have an initial point and it's going to have a terminal point, and we always have an arrow at the terminal end. But instead of calling them initial point and terminal point, I'm generally just going to refer to them as the head and the tail. So this would be the head, this would be the tail, and yeah. So that's how I'm going to be talking about them, is head and tail. Okay, so an example of what a vector, I guess, is you can think of the difference between speed and velocity, specifically in more of a physics type application. Speed is just how fast something is going. Velocity includes not only how fast, but in what direction. So if I say I'm going 60 miles an hour, that's a speed. But if I say I'm going 60 miles an hour east, that's going to be a velocity. That's going to be a vector because I told you what direction I was going. So vectors have a magnitude and a direction. And that's why we have a head and a tail, because the head, distinguishing the head from the tail tells us which direction we're going. So that's important. And we're going to write it either by a small letter like this, or terminal point. If the points are labeled, you can write the initial point, terminal point with a arrow on top, and that also means vector. A lot of times, even with the small numbers, I'll write it like this, because notice that this is bold. So you're supposed to be able to say, okay, if it's bold, then it's a vector. But when I'm just writing, I can't make it bold. So I would just put a vector symbol on top. And then it's even more obvious that it's a vector because who's paying attention to whether or not it's bold? So that's how I would write this, is just V with an arrow on the top, because I'm given the letter V. If I'm not given the letter V, I would have to do A, B with an arrow on top. Okay. So let's look at these true or false statements. So a vector is a directed line segment. That's true. That's one way of thinking of a vector. Vector has only size. That's not true. Remember that vectors specifically have a size and a direction. So saying that it has only size is not true. It also has that direction. A vector has an initial point and terminal point. Well, clearly that is true. So there we go. All right, let's move on. So here is our first example. And first, we're just going to talk about component form, I guess you could say, writing vectors in terms of their components. So basically, the components of the vectors are going to be how far it's going in the x direction and how far it's going in the y direction. So instead of saying, giving the names of the points, we're just going to say, okay, this one went up 4 and over 3. So where it is on the graph doesn't actually really matter. What matters is the magnitude and the direction. So by saying how far it went up and how far it went over, we are giving both magnitude and direction. So UT, right, that would be what we could call this vector, is UT is going to be, and then when we're writing the component form, we use these sort of angle brackets. So instead of using parentheses, we use angle brackets to show that this is a vector. So angle brackets, and then how far it went to the right is going to be 3, right? So it starts at 2 and it goes to 5. So you could count it on the graph, or you could just subtract. 5 minus 2 is 3. So that's 3 in the x direction, comma. And then in the y direction, it went 5 minus 1. So that's 4. So that would be the component form of UT. So let's look at RS, and remember, haha, that's not UT. That's not UT. Silly me. It's TU. It's TU because T is the initial point and U is the terminal point. So you always want to go in the direction that the vector, I keep wanting to say vertex, the vector is going, right? It's going from T to U. So that's the order that you need to write them in. And I just wasn't paying attention. So sorry about that. All right, so for RS, that actually is RS. We are going to do x direction first. So -1 minus -2. So we're going 1, right? But we're going 1 to the left. So right and left matter, right? We're going to the left. So that's the negative x direction, right? So it's -1. And you'll get the correct sign, by the way, if you do head minus tail. So -2 minus -1 is -1. So if you do head minus tail, you'll get the correct sign on your on your numbers. So head minus tail. Or you can just look at the graph and see it's going to the left, so that needs to be negative. But yeah, so S minus R. And then, so here we get -2 minus 4, which is -6, which makes sense, right? Because it's going down. So down is the negative y direction, so that's -6. So that's going to be -6 and angle bracket. So this would be our component form for RS, right? We're going down and to the left, so they're both negative. This is up and to the right, so they're both positive. So that's going to be important. I'm going to go ahead and stop this video here, and we'll have the next example in the next video. And I hope this helps, and I will see you there.